Hello, everyone. Thank you so much for joining us today at the Ocean Innovators webinar, featuring winners from our first Ocean Innovator Award cycle. My name is Adrienne Lawfer, and I'm the CEO of Sea Solutions, who's hosting this award and the related webinar. To kick us off, I'm going to start with some housekeeping, and then we will talk about our winners and this award. Attendees will be muted throughout the webinar with videos turned off. Closed captioning is available by clicking the CC button. There are going to be opportunities for Q&A with the winners, so while they are presenting, please send any questions that you have through the chat. We will be monitoring and collecting questions for the Q&A portion. And if you have any technical issues, please chat Katie Bear-Nalvin, or you can email her at katie@sea-shoresolutions.com. All right. The Ocean Innovator Award is hosted by Sea Shore Solutions, a women-owned environmental consulting firm focused on creating and implementing innovative solutions to support meaningful coastal management and marine policy. With backgrounds in state government, nonprofits, and other NGOs, our team provides high-quality, innovative solutions that bridge the gap between best available science and application. That space of application can be through ocean and coastal management, such as management planning and climate-ready management, policy, such as federal consistency and policy revisions, communications, including outreach and resource development, and technology, such as mapping, GIS, and decision support tools. In addition, we also provide wraparound services to support project management and overall team support. As a company, our work and initiatives are informed by our 5 values: collaboration, strategy, science, innovation, and outcomes. Clearly, this webinar is related to that innovation value of ours. We also operate through a nature-based business model, which highlights the importance of continued education and staying top of emerging technologies and findings in scientific literature. So to help us achieve this value of innovation and our continued education through the nature-based business model, we've developed a one-of-a-kind Ocean Innovator Award. This award serves 2 main purposes: to increase the visibility of high-quality, innovative solutions and support early career professionals. We plan on hosting this competition yearly, seeking creative applications such as videos, story maps from early career professionals in coastal, ocean, and estuarine fields, showcase innovative science or projects that contribute to salient ocean topics. These projects can be in any stage of the process to apply. And then applications are reviewed by a panel of experts in the ocean coastal field, ranging in specific expertise in geography, and the winners are awarded up to $2,000 and showcased in this webinar. The next competition is expected to open in February of 2025, and we'll send notification of this to everyone who registered for the webinar today, just in case you're interested or know somebody who might possibly be interested in applying next year. It now brings me great pleasure to announce our 2024 winners of the Ocean Innovator Award, Arona and Pilar Rodriguez. These winners excelled in their innovation and scientific rigor, bringing new solutions that are directly applicable to real challenges faced in the ocean and coastal space. First, we will hear from Pilar Rodriguez about her project that utilizes new technology to address the vessel traffic type gap in conventional whale ship strike risk assessments. That's a long title, but really interesting project. Pilar began working at the Marine Mammal Center in 2023 as a cetacean ecology research intern. After her internship concluded, she was promoted to her current role of cetacean conservation biology apprentice. In this role, she participates in boat-based cetacean surveys of the San Francisco Bay and offshore waters, large whale necropsies, and disentanglement responses. She currently assists with permit and grant reporting, mentors current interns, produces sighting maps in ArcGIS Pro for various policy and management committees. Prior to beginning at the center, she earned her Bachelor of Science in Marine Biology from Texas A&M University. While in school, she was an Aggie Research Scholar and interned with the Texas Marine Mammal Stranding Network. Pilar's research interests broadly encompass understanding anthropogenic risks to marine mammals, especially cetaceans, to inform conservation strategies. This led her to completing her project that she will share with us today. With that, I will hand it off to Pilar. Please remember to add any questions that you may have throughout her presentation in the chat, and we will get to those in the Q&A afterwards. All right, Pilar, I'm going to stop sharing now, and then you're free to take the reins.
Let's see.
Everything looks great on our end, Pilar.
Awesome. Well, thank you so much, Adrienne, for the introduction. As she said, my name is Pilar Rodriguez. I'm a cetacean conservation biology apprentice at the Marine Mammal Center, and I'm very excited to share with you today my project, utilizing new technology to address the vessel traffic type gap in conventional whale ship strike risk assessments. Vessel collisions are one of the many anthropogenic threats cetaceans, which are whales, dolphins, and porpoises face, especially large baleen whales. To address this threat, scientists create whale ship strike risk assessments for areas that serve as both a cetacean habitat and a major waterway to calculate the risk of whale ship collisions. These assessments involve using whale species distribution data along with vessel traffic data to report temporal and spatial risk of collision, which then goes on to help inform management strategies to try and minimize risk. Here we have a couple figures from Blondin et al. 2020, where spatial and temporal risk were calculated for blue whales in part of the Southern California Bight. Traditionally, these risk assessments, like this one, utilize the Automatic Identification System, or AIS, to obtain their vessel traffic data. AIS is a digital positioning system that operates in the very high-frequency maritime band and was originally created to avoid ship-to-ship collisions and give vessel operators information about their surroundings. It continuously transmits information such as a vessel's identity, voyage information, position, and speed to all other vessels equipped with AIS, shore stations, satellites, and any AIS receiver in range. Because of this, AIS data is readily available for use in ship strike risk assessments. However, not all vessels are required to be equipped with AIS, and only commercial vessels 65 feet and longer, vessels certified to carry more than 150 passengers, and nearly all towing vessels are required by federal law to broadcast AIS. So risk assessments that use AIS to get their vessel traffic data are not getting the full picture of vessel use. Risk assessments that only use AIS for their vessel traffic data may underestimate risk to whales. As you can see in this photo, small vessels that don't meet the specifications for requiring AIS also interact with whales. And while smaller vessels may not pose as much risk for mortalities, vessels of all types and sizes are capable of inflicting lethal force. There are currently a variety of strategies being used to track non-AIS transmitting vessels, including the use of a protected seas marine monitor system, which I'll be referring to as M2. The M2 collects AIS and non-AIS transmitting vessel data, and it does this through a radar and a camera that captures all vessel traffic and an AIS receiver. The radar uses electromagnetic pulses to locate vessels and determine their speeds. One of the ways the M2 provides data is through what's called vessel tracks. These vessel tracks chronologically connect individual detection points and report a vessel's unique voyage and identification number, vessel type, start date and time, and minimum, maximum, and average speed. For AIS transmitting vessels, the vessel type is reported as a number that's received through AIS, and vessels without AIS need to be manually tagged according to the photographs associated with their tracks. This photo here shows the view of the M2 that I used for this project. It's located near Point Bonita Lighthouse, overlooking the Golden Gate Strait, which is the entrance to San Francisco Bay. The San Francisco Bay Delta is a highly urbanized waterway. Sprawling 1,600 square miles, it's the largest estuary on the west coast of the Americas. And as seen in this photo, there are 4 major ports located within the bay, with the Port of Oakland ranking 11th in the amount of waterborne container traffic by port in the United States in 2021. Along with these 4 in the bay, 2 more major ports, the ports of Stockton and West Sacramento are located inland but require navigation through the bay to reach them. But despite this urbanization, the bay is home to many marine and aquatic species and is utilized by 4 species of cetaceans, including 2 large whales. The 4 cetaceans that utilize San Francisco Bay are humpback whales, gray whales, harbor porpoises, and bottlenose dolphins. This overlap in waters that serve as a cetacean habitat and a major waterway leaves them at risk for collisions with vessels. For example, during my time with the Marine Mammal Center, we witnessed a gray whale, TMMC 1-6, nicknamed Lychee, pictured here with a suspected ship strike wound. Lychee was observed in the bay for a record 75 days from first to last sighting. And while Lychee survived an initial ship strike, he was struck again behind the cranium by a vessel, which was concluded to be his cause of death. So to address this issue and investigate the data gap created when only AIS vessel data is being used in ship strike risk assessments, my objectives for this project were to determine the composition and seasonality of vessel tracks that came from AIS transmitting versus non-AIS transmitting vessels, investigate non-AIS transmitting vessel traffic trends and composition, and determine if fog affects vessel activity and speed. Methods. Here we have a map of my study area. The star indicates where the M2 is located, and the blue shows the study area, which was defined by the range of the M2 radar. Since AIS can be received from much farther distances than the range of the radar, AIS tracks were clipped just to this area. The Golden Gate Strait lies west of the Golden Gate Bridge and is a significant waterway for study, as all whales and all vessels entering by water require navigation through it to enter San Francisco Bay. For data collection, non-AIS transmitting vessel tracks were manually tagged according to their vessel type using the M2's archive, which was accessible through their website. This here is a screenshot of the dashboard. It has a list of tracks where users can view them on the map and view the associated photos for each track. Vessel types are added to the notes for each track and become a part of the track's data. Because the radar captures all vessel traffic, the M2 contains an algorithm that removes duplicated AIS radar tracks. Looking at this screenshot, we have 2 AIS vessels, the Cronus Leader and the Enhydra. The AIS tracks have their associated MSSI number and vessel name if applicable, and the AIS data is in the same format as the radar data. Since the AIS duplicates get removed, separate extraction of the AIS data and the vessel data detected just through the radar makes comparing AIS versus non-AIS transmitting vessels possible. And from here on, the term radar will be used to describe vessels that were collected only through the radar, meaning that they were not transmitting AIS. And here we just have a couple of random examples of vessel photos taken from the M2 of AIS vessels and radar vessels. My study period consisted of a full year, September 2021 through August 2022, but due to time constraints, a random sample of 4 days from each month were tagged, and radar and AIS tracks were pulled from those days. When investigating seasonal trends, the season breakdowns were as followed. Winter was January, February, March. Spring was April, May, June. Summer was July, August, September. And autumn was October, November, December. For Objective 1, to investigate AIS versus radar vessel tracks, the following vessel classes were used: cargo, commercial fishing, pleasure craft, tanker, tug, other, which consisted of all other vessel types, and unknown, which were vessels that could not be identified due to an obstruction of the camera. These classes were defined by the vessel types reported with AIS. Since AIS has set vessel types, the radar vessels were classified to coincide with these AIS classes. Since Objective 2 is only investigating trends in radar vessel traffic, these classes were not defined by AIS, and I had freedom with constructing these classes. The classes I chose for comparison were small motorized, large motorized, commercial fishing, sailing vessel, and recreational motorized. During analysis, recreational motorized was not directly compared against the other classes because recreational motorized consisted of vessels that were also in small motorized and large motorized. And I found it important to isolate the recreational motorized vessels since they are more autonomous than commercial vessels. For objective 3, to determine if fog affects radar vessel activity, the following conditions were used: clear, moderate fog, and heavy fog. Days that were clear had no tracks with fog. Days that were considered to have moderate fog had at least one track and up to 30% of the day's tracks with fog. And days that were considered to have heavy fog had greater than 30% of the day's tracks with fog. And when investigating vessel speed, individual tracks were compared solely based on if the track was clear or had fog. And here we have an example of what a track with fog looked like. Now for my results. For objective 1, when looking at the total composition of vessel tracks, 80.7% of all tracks came from non-AIS transmitting vessels. This means that most of the vessel traffic in the Golden Gate Strait is missed when only looking at AIS data. Now looking at the vessel classes, as expected, 100% of tug, tanker, and cargo vessels were transmitting AIS. This makes sense since all these vessel types likely meet the specifications for requiring AIS. 100% of commercial fishing vessels and 98% of pleasure crafts did not have AIS. This shows that vessels that don't meet the AIS requirements are not likely to voluntarily equip themselves with it. 81.7% of other vessels did not have AIS. The larger number of AIS vessels and other can likely be attributed to there being a number of other AIS vessel classes that were not included and include vessels such as cruises, pilot boats, and ferries that all frequent the area. And 100% of unknown vessels came from radar because vessel type is always broadcasted with AIS. And while the camera on the M2 is very beneficial and allows for identification of radar vessels, if there's any sort of obstruction of the camera, we are only able to know via the radar that there was a vessel and that it was not transmitting AIS. When looking at seasonal variations in radar traffic versus AIS traffic, radar traffic varied seasonally while AIS traffic did not. When looking at the number of tracks per day between the seasons, summer and autumn were the dominant seasons for radar vessel tracks. And the red brackets indicate that in summer, there were significantly more radar vessels per day compared to in winter and spring, using a significance factor of 0.05. For objective 2, when looking at radar-only traffic trends and composition, summer had the highest volume of vessel tracks, as indicated previously, and had the most vessel traffic across all classes. Across all seasons, small motorized vessel tracks prevailed. For small motorized and large motorized vessel classes, using a significance factor of 0.05, they had significantly more tracks per day in summer compared to the rest of the seasons. For the class commercial fishing, there were significantly more tracks per day in summer compared to spring and autumn. And the class sailing vessel did not have any significant differences across seasons. When looking at motorized recreational vessels, these two were most abundant during summer and had significantly more tracks per day than compared to the rest of the seasons. For objective 3, here we have a graph showing the average number of tracks per day for each fog condition. Looking at the graph, you can see that fog does not deter radar vessel operators. And it actually appears that moderate fog and heavy fog days have higher vessel activity than compared to clear days. But further investigation needs to be done due to the variation in sample sizes. And here we have a graph showing the average speeds of individual tracks for tracks without and with fog. Again, you can see from the graph that fog does not affect radar vessel speed. Both of these results are concerning when it comes to risk for whales. As you can see in these photos, the presence of fog greatly affects visibility. On the right is a photo of a humpback whale blow. with the presence of fog, which is extremely difficult to spot. The poor visibility decreases the chances of vessel operators spotting a whale in their path, and since there is no reduction in speed with the presence of fog, if a vessel operator does spot a whale, they may not have enough time to stop or take evasive measures. Key findings. My key findings were that 80.7% of all vessel tracks came from non-AIS transmitting vessels, that radar vessel traffic prevailed in summer across all classes, that small motorized was the most abundant radar vessel class, and that fog does not affect vessel activity or speed. The main finding from my project was being able to see just how much vessel data is being missed in ship strike risk assessments when only AIS data is being used. This graph shows the number of vessel tracks across months, with only AIS vessels on the left and with AIS and radar vessels combined on the right, with the average number of gray whales in orange and humpback whales in green across years in my study area. As you can see, the difference in vessel traffic when only using AIS versus AIS and radar is drastic. You can also see from these graphs that AIS traffic doesn't vary much temporally, while radar traffic does. This distinction is vital information when it comes to accurately assessing risk to whales, as whale presence varies seasonally. When looking at the graph on the right, you can see that in May, there's an uptick in gray whale presence and vessel traffic, and that humpback whales are present during the summer months when vessel traffic is most abundant. Inclusion of all vessel traffic is important to accurately assessing whale ship strike risk because while all vessels are capable of inflicting lethal amounts of force, sublethal injuries can negatively impact vital functions such as foraging and reproduction. Here are a couple of two known whales. On the left, a gray whale nicknamed Morse, and on the right, a humpback whale nicknamed Prop Mom, who have both been involved in ship strikes causing sublethal injuries, which you can see. Future work includes identifying risk imposed by non-AIS transmitting vessels, utilizing the M2 to create a whale ship strike risk assessment, using the M2 to help inform conservation and outreach efforts. With the M2, we are able to have a more comprehensive understanding of vessel traffic, which can be used to target specific boater types during specific times of year based on when whales are present and which vessel type is most abundant to make efforts more effective. And future studies can be done utilizing the M2 to investigate other vessel-related risks to whales, such as noise pollution and disturbance. Here we have my references. And I'd like to thank you all for your time. And I'd also like to give a special thanks to everyone who made this project possible, including Samantha King and Protected Seas, the Cetacean Conservation Biology team at the Marine Mammal Center, especially Becca Lane, the Berglund Foundation, the GEM Project, and Anna Sweeney. And now I'd like to welcome any questions.
Wonderful. Thank you so much, Pilar. It's really fascinating, all of this work. I'm wondering, if you can talk about any management strategies that are currently in place in the San Francisco Bay to help mitigate whale ship strikes, and how do you think your results could potentially impact management approaches? And while you're answering that, please, anybody else, if you have questions, add them to the chat here for Pilar.
Yeah, so in San Francisco Bay, there aren't actually any current management strategies in place specifically to mitigate ship strike risk. However, there are other management strategies for sort of like navigation safety for the larger vessels that include them traveling at a speed of 15 knots or less in the bay, but 15 knots is still above the recommended speed to help mitigate ship strikes, which is 10 knots. But at the Marine Mammal Center, we are currently working with our local Harbor Safety Committee with a marine mammal work group to kind of have these conversations and find solutions to this. And my work specifically can help with this in kind of like targeting times when management strategies should be more enforced versus when not, and kind of utilizing the robust understanding of vessel traffic trends to really get a fine scale risk assessment so management strategies can be most effective.
Fantastic. Thank you, Pilar. Um, and it sounds like this approach, I feel like there are definitely other regions that could potentially benefit from this. Do you think that this work could be applied in other areas? If so, like what are the challenges or opportunities that might impact those additional applications?
Yeah, I definitely think this can be used in a variety of different areas. And the M2 itself is used currently for different things, sort of like marine protected areas, monitoring. I think that's the main purpose right now for the M2 system. But however, kind of like what I touched on during my presentation, there are certain limitations to the M2 itself, including the fact that the system needs to be fully functioning in order for it to work. If you're utilizing the camera to try and identify vessels, if there's any sort of obstruction, you won't be able to see what those vessels are. The range of the radar is only about up to 5 nautical miles, so it's not as like AIS can be transmitted very, very far distances, but the radar has this small range.
Absolutely. And then we'll just finish it off here. I'm wondering, like, what was the most interesting or surprising thing that you found across this project?
Yeah, I think just the amount of volume of traffic that is really being missed when only using AIS. I was not expecting it to be 80% of all vessel traffic that is just completely unseen in these assessments. And then I think also looking at the fog trend, seeing how fog does not affect these boaters, and seasonal fog is very prevalent here in the Bay Area. So that is a little concerning and good to know, definitely.
Fantastic. Thank you so much, Pilar. This is a really fantastic presentation and project. And your email's there. So if anybody has additional questions, please feel free to reach out directly. Would certainly love to see other applications of this across the US. So thank you so much. All right, now we will transition over to our final presenter, Arona Bender, who is the first place winner of the Ocean Innovator Award. She is a marine biologist and student currently pursuing a PhD in marine science and conservation at Duke University. With a background in biological sciences from Georgia State University and a master's degree in marine and environmental science from Hampton University, her research interests broadly include conservation strategies for population recovery or maintenance of marine mammals and sea turtles. Arona is particularly interested in conducting international interdisciplinary field research that focuses on the impact of climate change and anthropogenic disturbances on sea turtle populations. Using satellite-linked telemetry, her dissertation investigates the inner nesting habitats, foraging grounds, and migratory corridors of sea turtles nesting along Guyana's shore. She'll also use drones equipped with thermal cameras to enhance monitoring of remote nesting beaches, improving data collection in the region. Through her studies, Arona aims to inform effective conservation measures that protect the well-being of endangered species and their critical habitats worldwide. Remember, please add any questions that you may have for her in the chat, and we'll bring up her presentation now.
All right. Okay, perfect. Thank you so much for the introduction, Adrienne, and good afternoon or good morning, everyone, depending on where you're zooming in from. My name is Arona Bender, and like Adrienne said, I am a second-year PhD student at Duke University in the Marine Science and Conservation program. And today I'm excited to share with you an upcoming project that I'll be working on as part of my dissertation that is entitled Unmanned, Women and Technology, Advanced Sea Turtle Conservation in Coastal Guyana. Next slide. Thank you. And so my dissertation holistically is me trying to look at the ecology, behavior, and the conservation of sea turtles in Guyana. And in particularly, one of my chapters will be on using thermal infrared drones in order to delineate or in order to detect the nesting activities of sea turtles that are nesting along the shores of Guyana. Next slide, please. So this is where my study site is located in Region 1 of Guyana, and it is on the northwesternmost side of Guyana at the tip, and it's also closely bordered to the Venezuelan border as well. And the Shell Beach protected area is roughly about 75 miles of protected coastline that consists not only of beaches, but also of mangroves and a wide range of ecosystems there as well. And so this is just an aerial view of what it looks like from above. And unlike the beautiful waters, crystal blue waters that you'll find along the Caribbean shores, along Guyana, we actually have some really nice chocolate milk waters along our shores, and that's just because of the sedimentations that are there. And next slide. And so this is just a video of what Shell Beach looks like when you're on the ground. And so as you can see, there's quite a lot of debris that comes up from time to time in this area. And so along the coastal shore, we have 4 out of the 7 species of sea turtles that nest there. The first one being the leatherback sea turtle, followed by greens. And then we also have hawksbills as well as olive ridleys that nest there. And in the past, we did have a lot of leatherback sea turtles that would nest in the hundreds, but as of recently, their numbers have declined. And we're now seeing a few more greens nesting than leatherbacks. And then we occasionally have the hawksbills and the olive ridleys that would nest there as well. And so in the 1960s, this area was discovered to be the nesting site for these 4 species by Dr. Peter Pritchard, who is a world-renowned sea turtle conservationist. And he actually visited this area in the early 1960s when he heard about it from someone when he was trying to have his summer vacation there during the 1960s. And it was then that he actually discovered these 4 species and started to write a lot of documentations on the species that were there. Next slide. And so it was during that time, the 1960s and the 1970s, that Dr. Pritchard would go and visit Shell Beach, and he would record and document all of the species that were there and their nesting trends and abundance. And he actually published several articles about Guyana's turtles in those years. And so it was from his frequent visits that he would go there that he was able to establish a relationship with the community in the area. And it was from that relationship that was established that one of the first community-based sea turtle conservation project was established, in which all of the local community members were a part of the program, learning about sea turtles, learning more about their lifestyle, their history, how they can protect them, how they can conserve them, and different measurements and different information that they can collect from these sea turtles. And so he had the local Tashao, or the local village leader, as they are called, to be a part of this program to protect these species there. And so it was from this community-based sea turtle conservation project that the nonprofit organization, the Guyana Marine Turtle Conservation Society, was established. And they continued the effort of protecting sea turtles and its environment, so the entire Shell Beach area. And besides from the conservation of sea turtles there, they actually held a lot of community outreach programs as well as education awareness programs as well. One of which being where they would invite students, local students, to come to Shell Beach in order to learn more about sea turtles and witness them nesting and laying as they're there. And it was from this nonprofit organization that it led to the process of Shell Beach being declared as a protected area in 2011. And so once it was established as a protected area, in 2015, the government agency, the Protected Areas Commission, they were the ones that assumed oversight of this Shell Beach protected area, and they continued the work that was first started out by the community, and their main objective was to establish, maintain, manage, promote, and expand the protected area. And so this area is managed under the IUCN Category 6. And so this focuses on providing natural products and services for local needs while protecting ecosystems and maintaining ecosystem services. And so along the Shell Beach protected area, there are 10 known beaches there where sea turtles typically nest. And the main one, which is Alma Beach, is the main beach that is constantly being patrolled, and it's currently the primary focus of the PAC's monitoring program right now. However, in recent years, there has been a lot of changes to the shorelines of Shell Beach. There has been rapid beach erosion that is occurring in this area. During the late 1990s, there was a vibrant community there, and there was approximately 150 individuals that live directly on the beach itself. However, because of erosion that is happening, as of 2024, there's only one family that currently lives on the beach compared to what it was in the 1990s. And so, because of the rapid beach erosion that's happening at Alma Beach, there are other challenges to monitoring the other beaches along the Shell Beach protected area. Two of them being that it's very labor demanding and there are a lot of financial constraints to um, monitoring these beaches. For example, some of these beaches, it takes a lot of effort to carry all of your equipment there, as well as a lot of fuel and cost to get there, because the main way that you can get to these remote beaches is by boat. And some of the beaches are also very challenging to access, and that's mainly because there are not there's no necessary pathway that you can walk in order to get there. And so because they're not able to go to these other beaches to effectively manage and monitor these beaches, it prevents a full assessment of the sea turtle population that does nest along Shell Beach protected area. And so, because of this gap, that is where my research focuses on trying to develop a monitoring approach that will allow for regular surveys of sea turtles nesting in areas of Guyana that have not been previously monitored before. And so, with the funding of the National Geographic and the Sea Source Solutions, that is where my drone project comes in, and it has been inspired by a previous or a previous study that was conducted by Seos Rios in 2022, where they also looked at a beach in Costa Rica and they also used the thermal infrared drones in order to see how well the thermal infrared drones that they use could detect nesting activities versus regular ground patrols that are happening on the ground currently. And so for the drone project, what I plan to do is use a DJI Mavic 3T drone or the 3 thermal drone. And with this drone, it will allow me the ability to do several several different things that will help in the establishment of learning and understanding more about the nesting activities that the turtles are conducting. And so the first great aspect about this drone is the thermal imaging sensor that it has, which can detect heat signatures or the body signatures of sea turtles as they come along the shores to nest. And so once we're able to detect the heat signatures, we can also identify the various nesting sites that each turtle is at. And so with the high resolution and zoom, I'll be able to have or review detailed observation of what's happening or at what stage the turtle is at during the nesting activity. And then I can also be able to zoom in from a distance above in order to potentially detect not only the turtle or what stage of the nesting activity they're at, but also potentially detect if that turtle was previously tagged with a flipper tag. And I can also try and see if there are other aspects of the nesting that I can see while hovering over that nesting site. And so with this particular drone, the flight time is roughly 45 minutes. And so it will allow me a longer time frame in order to monitor the beach, or if I need to stop at a particular species or a particular turtle, hover over them for quite some time before I need to bring the drone back to base. And then also with this drone, I'll be able to analyze the data by looking at the screen to see exactly what's happening several a few distance away. And so it also has the really nice aspect of environmental adaptability. So I can do both night and day operations because not only does it have the thermal infrared sensor, but it also does have an RGB camera. So I can perform missions or flights throughout the day as well in order to detect tracks and see if there might potentially be like a dawn turtle or maybe some hatchlings that are now emerging as well. And so in Sayos Rios, her study in 2022, what she found is that the drone compared to regular ground patrolling actually did have a higher detection of activities happening, not only for the turtle activity, but they were also able to detect other wildlife as well as nest predators and people or potential poachers who are out there trying to collect the eggs as well. And so what she found was that the drones well outperformed all of the other, it outperformed the regular ground patrolling that they typically conducted. And so the objectives for my drone project is to first conduct a capacity building for the PAC Rangers and the local community by holding a drone workshop. And secondly, it is to create a standardized protocol for nocturnal drone monitoring within the Shell Beach protected area. Thirdly, I want to demonstrate to regulatory agencies the benefits of incorporating UAVs to improve data collection and enhance what data is already collected as well. And lastly, I do want to bring an educational component to this project, to the local schools that are in the neighboring regions. And I want to engage with students to explain how drones can be applied in environmental science so they are aware of the different techniques that are out there to monitor the environment that they are all a part of. And so some of my expected outcomes, first is empowerment and skill development. So with training the PAC Rangers and the local community It will equip them with valuable skills in drone technology, as well as enhancing their ability to monitor and protect the environment so that these skills that they now obtain, they can continue to use them for future monitoring. Enhance conservation efforts. So I do want to create a standardized method that can improve the accuracy and efficiency of monitoring the nighttime activities of sea turtle nesting so that it can lead to better informed conservation strategies. And thirdly, it's policy influence. I do want to show the regulatory agencies the advantages of using UAVs so that it can potentially lead to policy changes that will incorporate advanced technology in environmental monitoring. And in that way, they'll have a complementary kit within their toolbox. And for the educational outreach, engaging in students will foster interest in environmental science and technology, potentially inspiring the next generation of conservationists and scientists to know what technologies are out there for them to use if environmental science is a field that they want to pursue in the future. This project is expected to start next year in March of 2025, and that is roughly around the time of the peak nesting season for leatherbacks and greens, and potentially opportunistically seeing hawksbills as well. And so the next steps that will happen for this project is to first conduct the capacity building workshop directly on Shell Beach with the rangers while they're there. And then next will be to create or develop the standardized protocol once we're able to have the flights and see which sort of options work best once we perform the flights. And then after which it will be analyzing what we were able to collect and writing up a final report that I will share with the regulatory agencies. And then next it will be the education outreach to one or two of the local schools in the neighboring region. And so I have several collaborators for this project. The Protected Areas Commission and the Environmental Protection Agency are both governmental agencies in Guyana. And then I'll also be partnering with the Duke Marine Robotics and Remote Sensing Lab, as well as the Barima Mora Passage Drone Unit. And then other collaborations include the Guyana Marine Conservation Society, as well as Real Guyana, to potentially develop a documentary on what we're doing, as well as the Guyana Civil Aviation Authority in order to collect the necessary permits and waivers that I will need in order to fly the drone. And I'm particularly interested in working with the Barima Mora Passage Drone Unit because they are an all-female drone unit that was established by the Guyana Marine Conservation Society in order to train women from different parts of the region in order to get the technical expertise that they need in order to take this knowledge back to their communities in order to monitor and perform different environmental projects. And so one of the projects that they are currently working on is monitoring the mangrove forest within the Barima Mora Passage area to detect if there are any illegal activities that are happening within that region. And so that's just one of the ways that they're able to take back the knowledge that they've learned from the training that they've received in order to continue to help their community and continue to build upon what their community needs are. And so working with them will be a sense of women empowerment because the drone field is very male based, especially with the type of technology that is used. It's heavily predominantly males that you will find working in this this sector. And so establishing the relationship with this drone unit, we'll be able to continue to help out in areas that they need, and so continue to just establish different regions that they need to continue to work on with this. And with that, I'd like to say thank you so much for listening to my talk, and I'll take any questions that you'll have right now.
Fantastic. Thank you so much, Arona. This was a fantastic presentation, and it sounds like that project is going to be really fascinating. Well, folks, add any questions that you have to the chat. We fixed the chat issue, so thank you for letting us know. I will go ahead and ask you, Arona, when you're doing these drones, is there any like specific nesting activity that you're looking for, or anything in particular that you're interested in exploring? It sounds like there are a lot of things that happen on those beaches, so you could find a lot of different things.
Yeah, there's a lot of different activities that happen at nighttime on those beaches. And so the main nesting activities we'll be looking at is first trying to identify a sea turtle. Secondly, if we can identify a sea turtle and their tracks. Also, we're trying to identify if they're in the stage of nesting, if they're like starting to lay their eggs, or if they're body pitting, or if they're digging their egg chambers. So these are some of the different nesting activities we're looking at. Also, trying to see if while they're performing these activities, if there are any potential predators around, or predators around the nesting activity itself.
Fantastic. Thank you. What are the main challenges that you anticipate running into throughout this project?
Yeah, so some of the main challenges that I anticipate are the natural elements. So, for example, the weather would be a big challenge. The time that I'm going is during the dry season, but if I do end up staying around May, June, when it's the rainy season, the rain will be a huge challenge, because this particular drone, I won't be able to fly it during once it rains, or if the wind is very high, then I won't be able to fly it then. But another potential technical challenge would be battery life. So since this is a very remote area, I will need to walk with several batteries for the drones in order to deploy several flights or several missions. And so if the generator at the area that we're at is turned off, then I won't have the ability to charge the drones or to charge the batteries. So that would be another challenge as well.
Absolutely. That kind of gets at another question I was wondering about potential application of this method in other areas. Sounds like weather is definitely one of the limiting factors, but I wonder, are there other limitations that folks should maybe think about, and when considering if they could bring this to their own region?
Yes. So, with this technique, it wouldn't, it's mainly for complementary reasons. So, once we're able to detect a turtle, there are still some things on the ground that needs to be done. For example, if it is like a neophyte or a new turtle that is nesting for the first time, and we want to attach a flipper tag on her, then we will need rangers or ground patrollers to actually go to the turtle and attach the tag on her. And so these are, well, that's just one example of, another thing that they need to take into consideration. While the drone would be a great tool to detect and observe what the turtles are doing, if a turtle needs a workup, or if a turtle is potentially stranded and needs to get back into the ocean, then we do need to have the ground patrollers there to continue to assist with them.
Yeah, that definitely makes sense. And just last question here out of pure curiosity, how long are you planning to be in Guyana for?
So particularly for this project, I will potentially be there for 2 to 3 weeks, but I do want to gain more experience in that area with the turtles and kind of like observe them throughout the entire nesting season. So I'm potentially hoping to be there for 3 months, which I'm mentally prepared for because it is very remote and you're living in like tents and it's not, like you're away from the comforts of your home. So it's very it's a very challenging area to stay in for 3 months, but I'm looking forward to it. I'm very optimistic.
Yeah, that's fantastic. If you need any other research hands, give us a call. It sounds amazing. Fantastic. Thank
Definitely.
you. Thank you so much, Arona and Pilar, for your wonderful presentations. And thank you everybody for joining us here today. I know we can all do a little round of applause for Arona and Pilar in our own spaces for really giving us some amazing presentations here today. So like I mentioned, we are going to be doing this award cycle again next year. Should be coming out February 2025. So stay tuned for that. And if you know anybody who might be interested in applying, feel free to send them our way. You can find out more information about this award and our work by emailing us, or you can follow us on our website. Thank you so much, everybody.